Okay, preparing to live stream. If you want to start your screen share or something, you can go ahead and do that.
Okay, yeah, I'm doing that. Just
looks like we are live on YouTube now. If you
Yep.
want to start. And I'll also hit the record button just to be on the safer side in case something happens to the stream. So we are good to go. Naga, you can start with your introduction and then we're good. You're good to start.
Okay. Hi everyone. I'm Naga Herakoni, and today we'll be solving few problems on priority queues and heaps. As some of you may be aware already that where priority queues are good at. Normally this priority queues or heaps, we have two versions. One is the min heap and the other one is max heap. So the min heap always ensures that the minimum is at the top, and the max heap always ensures that the maximum is at the heap. So depending on the need, you just make sure that you use the appropriate one. And the time complexity for the min or max is always constant, but for insertions or updates, if you want to add, it will be login typically. So let's get started with few problems on priority queues. And whenever you hear any top k elements or the kth smallest or whatever, whenever some top k word is used, there is a hint that possible that you can use heaps or queues. So I just picked 3 problems today. Because the last one is a little hard problem and we may need to spend some time on solving that. The first two are medium on lead code. With that, let's get started with the first problem. As you can see, the problem is about finding the kth smallest element. We are given a matrix and the elements are sorted in row wise and also column wise. Task is to find the kth smallest element in a this. So if in this case k was 8, so 1 2 3 4 5 6 7 8, so 8 smallest, I mean, so is 13.
So Naga, last time I also picked up similar question. We did a binary search, so good to see that you picked up for a heap solution.
Yeah, we can also use binary search, but I wanted to, I mean, at least in this session, to think in terms of using heap.
Yes. Yeah.
Mm-hmm. So yeah, any volunteers you want to tell any solutions that comes to your mind?
So this is a heap session, so I will go with heaps.
Okay, how you can use heap to find the kth smallest? Can you?
So generally, because so this question can come in 2 different variations, like k smallest, and you have only rows sorted, columns.
Yes, yes, yeah.
Then there could be one solution where you can take a max heap of the k and keep on adding elements. And if you see a smaller element in the heap, remove it and add a bigger element. Oh, sorry. We need a min heap, and just if you find a bigger element, remove it and add a smaller element in that. But although it is telling, it's told it is both sorted in rows and columns, then we can do a different way. We don't need a heap of size k. We can even the heap of size n.
Yeah, so as you can see, it's an n by n matrix. In this case, it's 3 by 3, right? 9 elements. I can ask for second, or I can also ask, I mean, up to the n cross n, right? Up to n. If we take the total number of elements as capital N, with 9 elements, so k can be much smaller than that. The only thing is that whether you add all the elements and then figure out what is the top k, or you just filter down some paths like until only k elements. If you, is there a solution where you can only go till k steps and figure out that this is the smallest element?
Yeah, you can, one thing, like you can add one to the heap first, right? The first element of the matrix. And now since the rows and columns are sorted, so you can, next you can, when you pop out one, add 5 and 10 to it.
You add both 5 and 10.
Yeah.
So what would be the next step then after you adding 5 and 10? Which way you go, right or down?
Again, no, again your 5 will be the next minimum. Initially you added one,
Okay.
right? So k was your 8. So k will be made to 7. Now after popping one, then you just take the next element 5 and 10, add it both to the heap, and take, now this time you'll have 5 and 10 in your heap. Now remove 5 from there because that is the minimum. So
okay, and next
5. So k will decrease to 6. Now next again 5's next is, since row is sorted, then take 5's next, that is 9 you take and 11 you take. So in your heap now 9, 10, 11 will be there. And after
how do
again
you keep
minimum,
track? But how do you keep track of how many elements are there in the heap and versus how many are pending to be seen? And I mean, like at what point you realize that it is kth element?
yeah, along with the element you will pass the indices also. Like when I pass 1 to the heap, I'll pass 0, 0 as the index inside, and I'll keep a visited track that I've already visited this item.
Okay.
Yeah. So when you insert first, I'll insert, yeah.
So okay, at what point you stop searching?
When k will be equal to, when k will be equal to 0, I mean every time when you pop, k will decrease. First time k was 8, then it will be 7, 6. The moment you reach 8, the moment k reaches 0, you'll have 13 as your smallest, I mean 13, what is that? Kth is smallest element.
Okay.
That would also mean that by the time you're done, there's still some element in the heap, right?
Yes.
What if you know you want to do k step only, and then by the time you're done, there's the heap is empty.
Yeah. It's not necessary that the heap will be empty. There can be elements in the heap at that time also.
So yeah, one thing that I notice is in your solution, I mean, like since you are adding 2 elements in each step, like whenever there is a possibility, there is a chance that there are more than one element remaining in the heap. So, but
I'm
still,
adding
I think
if index is I comma j, then I'll add I plus 1 j and j plus 1 I. Like 0,
yes.
0 is there, so I'll add 1, 0 and 0, 1. Again, when I'll get 5, 5 will be your 0, 1, so I'll add 1, 1, and that is 9 and 11 I'll add.
I think your solution looks almost close, but only thing is that you may be unnecessarily having more than required number of elements in the heap. There is a similar same trick, similar to the trick that you use. You can only choose to add one element at a time, and by the time you are done adding the k elements, you already have one element in the top of the, I mean, like after you finish the steps or k minus 1 steps, you will have the min heap with the peak pointing to the kth smallest.
So I was telling was start with 1, 10 and 12 and then do for k iterations and keep on removing element and adding a next element.
Yes. So in that case, like how do you decide to add the next element?
So if so initially in the heap 1, 10 and 12 will be there. So one is the smallest, 1 will go out and it will add 5.
Yes.
Then 5, 10, 12 will be there. 5 will go out and it will add 9. Then out of 9, 10 and 12, 9 is small, 9 will go out and it won't add anything. So our heap size will become small. Then 10 will go out, it will add 11. when
Okay. Yeah. Yeah.
and
So, yeah. So this.
But like you don't need to keep 1, 10, and 12 initially, right? Because you know that 12 will be greater than 10. So we don't need to put 12 in there, right?
Yeah. So, but I think his idea, like Sims, his adding 1, 10, and 12 will, I mean, all the elements either in the first column or first row gives us the ability to navigate to the next elements in that row. Suppose
So
like, yeah.
it's
Since the
actually that merge k sorted lists. The idea is that.
yes, it's very similar. Like if you're merging k sorted list using a priority heap, it'll be each row you can treat it like one list here.
Yeah, but let's say you have a lot of row, but small column,
Yeah,
right? So you have only 2 column. You have a lot of row.
It's
Then-
n by n.
Yeah, you can
It's
also.
It's n by n, so the rows will equal
Oh,
columns.
okay.
Yeah.
But in that case, let's say it's m by n, and m is smallest. So whichever is smallest, we can go.
You can do that. Yeah, whichever is smallest, you can do that.
Because it's sorted both ways.
So you can either like the way he has done, like you can add the first column. There is also possible that you can add the first row, and then similarly you can go vertical in that case. So either way, this will work.
Yeah. But it seems like somebody gave initial solution that also seems interesting.
Yeah, it works. Yeah, but only thing is that I think each time he's adding 2 elements instead of yeah. So that there is a chance that you may be adding more elements than necessary in a heap.
So is it like our heap size? So okay. The just a previous solution which we discussed, max heap size will be n.
Yeah, I mean, like in this case, like if n was 3 into 3, so basically n.
So the solution which I gave, the complexity would be k log n.
It won't be log n also, I think.
Yes,
because it will be log k because you still are only doing the min heap until the k elements, not on the total number of elements.
So k times I will.
Rows.
So minimum, whichever is the
log of number of rows would be the complexity, because you're adding n elements into priority queue.
Yeah, after that I'm doing k iterations also.
K iterations also, so it will be
Yes,
k. Yeah. I think k minimum of I mean like k plus log k. I think it will be like that.
So so the complexity would be k log n. In like that's what like my assumption. But I want to understand the complexity of the previous the other solution.
I think it is similar, but he's adding every time 2 elements. Though, like, with this
actually, he could add only 1 element out of the 2, but just he can check whether it is which is the minimum.
Okay.
Yes.
And just add 1. Yeah.
Yeah.
Also, you have a solution.
Can I ask a question?
Pardon?
Can I ask a question? How would you, in an interview, how would you go about diagramming this or walking through the steps of the solution for the interviewer? I'm unsure about how to show that.
Yeah, you just need to probably, like, since if you are using virtual editors nowadays, try to use your editor as much as possible. Like the first, in this case, you can actually like first row, and like the way Asim was saying, like if you add the positions of each element, like say let's take this pair of 0, 0, and the value is 1, and let's add another pair, sorry, and then 0, sorry, it's 1, 0. That's index of your approach, right? So when explaining the approach, you probably need to say that like you are either taking the first row or first column, and maybe by looking at the problem nature, you need to probably guess which are the data structures which might be data structures or algorithm which can work. In this case, binary search is also be possible, and also this priority queue, the fact that it is k smallest. So, so you just try to use as much as possible your editors to be able to explain the approach first, and definitely without finding the approach or solution which would work, even the interviewer won't ask you to start coding. So you need to just brainstorm a bit, first ask questions, clarifying questions, then brainstorm a bit, like think out loud along with the interviewer, since mostly interviews are remote now. You just make sure that you try to arrive at a solution and explain them the approach, and if they understand what you are saying, like the approach that you are explaining, they will ask you to start coding. So who wants to take up this, like writing the code for this?
Python I have.
So somebody told like we don't need to add. So I just first I want to lock down on which approach.
Which approach? Okay. I mean, like I basically whatever the approach you said, that can be done either like in two ways. First, we add all the column as you said, or we can also add all the row items and then go in one direction. The other approach that I heard is like initially you start with 0, 0, 1, and next time there are two possibilities of adding, right? Either you add the column next or row next.
No, but some with one addition also we can achieve that.
Oh, I didn't know that. Like with one
Take
addition.
a minimum of that 5 and 10.
Yeah, what I was saying is the Shashank, the way he is suggesting, add two elements. Instead of that, he can just compare which is the minimum out of that and then add it.
But
yeah, but I think the problem with that approach is you lose track of, suppose if I move forward from 1 to 5, I lose track of indices for 10 and 12, right? I won't be able to go back in a priority queue, using a priority queue.
So then you can use a pair, right? So you can use the value and then the column index and row index for that.
Exactly.
No, that's what, like every time you take this index and you see whether you need to go back or front, right?
Yeah, I think that makes
case,
it
time
really complex.
complexity increases in that.
Yeah. I think it can be done with that method, but I think it will make the problem will complex, like the solution.
Yes, it works, but like it increases the complexity, and the code complexity also increases.
What would be the complexity? Like anybody want?
In the worst case, you may need to go to the 11 and still go to the left and right. So if you go to the 5, then 9, and then like once you finish 9, maybe you might need to head to the 10, 11, 12.
So that's what I'm trying to understand. Like,
yeah, I don't know. Yeah, if
when I write code, then I think it will be.
Yeah, you can.
No, but I think before
explain the approach. Yeah, just try to explain with this approach. If you want to take control, you can take. Or let me see if I can give you the control here.
Wait, can you explain 0, 0, 1, what it means?
0, 0, 1 is I'm adding the first element into the priority queue. So the priority queue of if this is a pair is an object which has x, y indices, like the row column indices. This is the row index, this is the column index, and this is the value.
Okay.
So the format is like pair of row, comma, column, comma, value. And in the priority queue, the sort formula will be based on minimum val.
Yeah.
So someone wanted a control, right?
I can share my screen.
Okay.
Yeah, I think you can start sharing, right? Yeah, let me stop sharing. Do you have permission to share screen?
Pardon?
I think there is permission.
Okay. Shashank, right? Okay. I don't know if I can.
Yeah, I can share.
Okay.
So what I was saying, like, first I'll add one to the priority queue along with the, what is it, their position 0,0. And this is a visited set that I'm keeping track that I've already visited the
Visited
of
this,
this.
yeah.
Now you pop it out of from the heap, min heap. Now what I'll add position 1 to the right side. I mean this 5 and 1 to the bottom. So 5. So first I added 10. 0, 0, add 1, 0 and 0, 1 I'll add. I plus 1, j and j plus 1, I. So first I added 10 with its index 1, 0, and next I added 5 with the given position of the 5, 0, 0, 1, yeah. And I'm just appending all those indices in this visited set that I've already seen those elements. Now minimum of 5 and 10 is what? 5. So 5 will come out of it. Now once 5 comes, then you'll add 9 and 11 to it. So when you add 9 and 11, your heap will become 9, 11 and 10. Now minimum of these three is what? 9.
9.
Now when you reach, you can't go that side. That I'll take care that it should be less than your row length. So I'll add 13 to that. So when you add 13, it will be like 10, 11 and 13. And now pop the minimum element. Minimum is 10. And 10, I've already added to the visited set because when I was using 1, I had added already 10 at that time. So next time for 10 we'll go for 11, but 11 has already been added, which we'll get from the visited set. So we'll add 12, and when you add 12, you'll have 12, 13 and 13 in your set, and just pick the minimum out of it, 12. I think by that time K will be your over.
Okay.
K is 8, right? K is 8 after 13. The code I can
yeah. But you need to poll more elements to make sure that you reach K, right? Okay.
Yeah.
So yeah. So this is a good approach. I think that's what Naga was telling, that you might up ending adding 12, but you are also controlling that with visited. So yeah,
it still works. Yeah, it still works, but you are having some space complexity apart from priority queue.
Yeah.
And also,
yeah, in this I would say, like, if he compares before pushing in which value is smaller, and then only push that value. But then again, the index manipulation might be some bit more complex. Yeah, I think so.
So yeah, this is another way of thinking the solution.
I don't think visited is required. Is it really required there?
Yeah, because when you go to 10, you have already, when you were at 5, you have already inserted 11. But when you will encounter 10, again inserting 11 2 times.
That correct.
Oh, okay.
Yeah.
So you keep,
yeah, with this, you need to keep track of. That's one.
What if, like, you don't add the next row? You only add the next column, right? Then we might not need the visit because you only would go one direction only from left to right.
Yeah, in that case, he needs to again get hold of second row, right? Somehow.
Yeah.
Once he finishes the first row.
Yeah, he already have the second row, right? When he initially he added the second row.
He added the second row one. So he's adding both right and bottom. I mean, like top one, so below one. Sorry.
I plus 1 and j plus 1.
Yeah. So yeah, I think this approach seems good, except that like little space complexity extra apart from heap. and then like maybe few other elements in the heap, though while returning the result, but that's okay. So anyone wants to volunteer for the other approach which Asim told?
Yeah, so one approach which I could think of, but it do not require heap.
Yeah, so I think the other approach you can mention, but like I wouldn't recommend. I mean, like since we are discussing heaps, I wanted someone to write heap code. So, but you can mention like how you can solve. I mean, like solve on the other approaches also.
Yeah, so I'm thinking of two directional variable, one going from left to right, and other going from top to bottom, and each variable it's a pair of row and column, and uh, initially the left to right would be pointing to 5, yani means 0 or 1, and the top to bottom at 10 means 1 0. Okay, and I means I is equal to the k is I is equal to 1 we have already absorbed. So now we have to k minus 1 elements we have to check the loop k minus 1 times, and each time we check these variables, either we have to go in the left to right direction or top to bottom. So we would check which value is minimum, we would go that direction and increase that. So we have observed 1, then we have checked 5 and 10. The minimum is 5, then we go further in the left direction. Then again we check 9 and 10. 9 is the minimum, so we again skip 9, and this value will now both left to right and right to left would come to 10. And then these both are pointing to the same element, they are equal, so we can either go from top to the bottom would again go to the next row, or left to right would go to the next column, which we could take any one, and then by processing after kth element, after k iteration we would get the kth smallest element.
Okay, you just have like two kind of pointers, like which is like 2D small, like having like 0 0 versus like initially, and then something will be either 5 or 10. So
yeah,
and then you go with another pointer.
Yeah,
I think 2 pointer might not be enough, right?
No, I mean like 2 pointers of each pointer having XY. So in this case,
each pointer is a pair.
Yeah, each pointer is kind of a pair.
Yeah, but still only 2 pointer
without a value, but like he still wants to compare one on this down and one on the right.
Yeah, but at some case he might need n pointer, right?
No,
because let's say if the row is like in diagonal, right? So
he keeps going on the next smallest, either on the bottom or right side, until he the number of steps he takes hits k elements.
But let's say if the right on the first row, the right is big, so if you go to the bottom, right, he go to the next row, then he go next row, then he go next one, and now he travel down, and then he need to keep track, like which one will be the next. Right?
Yeah.
So I think that should work as well. So one question I had is from 1, when you go to 5 and 10, do you keep track of 10, or you lose that since 5 is the closest to 1?
No. So initially we have pointing to 5 and 10. Then we compare. So we found that from this left to right is smaller. Then we skip 5 and we go to 9. So our now next the left to right this variable, the tuple is pointing to 0 2.
So and do you lose the track of 10, or do you keep track of 10?
I think he keeps track of 10.
Oh, it sounds like each pointer is actually a tuple.
Yeah,
each pointer.
So this is one pointer and this is one pointer. So
yeah, 1 0 and 0 1, these 2 pointers.
Okay, yeah.
So now let's think about a test case. Instead of 9, you have 19. Replace 9 with 19.
Yeah.
Right?
So
then how would you go?
No, but it is not sorted on the column wise, right? But in this case, the problem is sorted both.
Okay, so we put like 13 become 20 and 21. Because right now, I think we need 3-pointer to.
No. At any point, we are only comparing 2 pointers, two places at any point. We are only comparing 2 places only.
Yeah, vertically one next to that one, and then horizontally one next to, I mean, the below it, and that will make sure that we get the smaller of that, so that it will maintain that integrity of sorted array, the row and the column, I think.
Does it say?
So we just need. Well, the only thing we need to make sure is if you have 2 items that are equal, that they both move both.
Yeah, the equal chance of returning both. So any of them is okay.
We can move it any direction. So means after 9 we have come to 10. So then that time
What I mean is you wouldn't. What I mean is that let's say, so here we're looking for.
Here the 8th element is 13 either on this side or this one. So both are valid.
Basically, you want to ensure that it doesn't get counted twice. So let's say in this example, K was 9. You wouldn't want the 2 13s to get counted as 8 and 9. Or
I think
you know
he's
what I'm
keeping
saying.
track of, he's not worrying about values. I think he's keeping track of pointers only.
Yeah.
I think it should, because when he moves to the next position, it hits like a new number, right?
So behave value.
What I mean is this. What I mean is this. You have the idea is to take K minus 1 steps, right?
Yeah. So 0, 0, I'm considering the first element. So next we have to have K minus 1 iteration.
Right. So if you have multiple elements that are the same value, you still need to keep track of how many steps you've taken, or do you need to adjust? Because
no. Still,
I'm not understanding if K smallest means, that
not the K distinct element.
If each.
Yeah, it is. Yeah, they're talking about not kth distinct. It is just element in sorted order. So.
Okay. Yeah.
The question clarifies that. Yeah.
Then it's okay. Yeah.
Not K distinct. Okay, but let's say I have the first column, they all value are all the same. Then how would you do? Like, first column, they are 10. Then how do you know, where to go next?
No. So
I think he compares, he moves the pointers this way, one here, one here. So he will have like one pointing to 5 and one pointing to 10. So he knows which direction to go, right?
No. So he's saying if instead of 5, it should be 10.
Okay. Yeah, all 10.
Okay. Then we can in any of the direction, either left to right or
okay.
Yeah.
Okay. Got it.
And I mean all the column, the first column at 10 too.
Okay.
So the initial first column at 10, right? So now, if you keep going down, then the next time you have to look for the next element, then you lost track because you have 2 pointers, you don't know where to go.
Yeah, so I mean, like if there are so many duplicate elements, this approach might lead to different directions. Yeah, it may not be efficient, but I think it could still work. But the way which direction.
But if first 3 columns are 10, then I think first 2 rows will also be 10. Right?
No, so it says that it's in ascending order, right? So if it can't all be 10, because that wouldn't be ascending order. That'd be like non-decreasing order. It's like a subtle difference, but
Yeah, correct. It says in ascending order, so it is not non-decreasing. So I think this is not possible in this example. So,
I think let's focus on the heap solution. I think that might be the better
so way. I think we need to head to other 2 problems, and if you want some time for the Skyline problem, I would encourage to move faster in this. So who is willing to code the other approach which Sim told? Asim, you want to write?
If there is no one, I can do.
Yeah, sure, you can do.
Okay, somebody's doing.
Yeah,
I'll do.
You can start sharing screen. Let me just stop.
So which approach you're going?
Your approach. But I have not written it, so I don't know if it is a good use of others' time. Okay. I'll be writing in C++. Is that okay?
Yeah, go ahead. Any language should be fine. You all should get used to other language syntaxes.
I'm just checking for where I kept it. If somebody is ready, then probably they should start, because
Asim, you want to go ahead? Maybe you can do the next one, Rajendra.
Okay.
Yeah.
Okay. Let me share my screen. Oh, please let me know when you can see my screen.
Yes, we can see.
Okay, so let me remove this binary search solution. Okay. In this thing, we'll take a heap. So in Java, it's done by priority queue. And to track the elements, so I will go with that approach which Naga you told.
Yes,
take
yes.
X, Y, and
Value.
And then I need to write a comparator, which will. So this should be a min heap. So I will take. So.
If you are keeping in the last, yeah, I have to.
So I think this syntax should be correct. So this is a way to tell, like, I want to do on this. So basically, like Naga mentioned, it would be row, column, and
Value.
Well, yeah. And we'll add a element in the priority queue. It should be 0, 0, matrix 0, 0. Should be.
You said about like adding all the column or all the row, right? Like one of the questions.
Or probably I'll start. First, I will. Yeah, you are right. So first, let me add all of them and then proceed.
So Asim, why do we need row and column? Sorry, I missed that part. Like just adding the value won't help. Like I add 159 and then I pick the, like, I take out the first element smallest and then I input 10.
Yeah, because you are only using the navigation from the heap elements and not using any other for loops. So you need a way to navigate to the next element in the row or column, right? Yeah, I think once he writes the code, yeah.
I thought we can run two loops, like add 3 elements first in this example, and then add the next loop from the first row and then keep on adding and pulling again.
Yeah, so I think to avoid that, we can do in this way. So.
And I'll bring this code inside.
Yeah, you can move inside and adjust the pointers.
And you keep on changing this guy and keep on changing this. And then, so I have 3 of them. Then I'll run a loop where while k is greater than
0.
I think it should be k minus n is greater than
K
0.
minus.
Because you've already put n elements. So yeah.
Yes.
So need to also see if k should be greater than n.
I think that condition. Oh yes. So you need to pick k is less than n square. So if yeah, I think
n here
this makes sense. Yeah, I think it
length,
makes
right?
sense.
Which one? Sorry.
Your n is they don't give you what n is, so you have to actually do something like matrix dot length.
Matrix dot length. Yeah, correct.
Yeah.
Like k should be greater than n.
Yeah, that is correct. Yeah, you need to take the min.
Okay, so if k is not greater than n, then that means that you've already put k the smallest out.
Yeah,
lines 10 through 12.
I think we can do k.
So you can check that like separately, I guess.
So we already, I think we can even do this thing. What do you say?
Okay, smallest. If it was k was 2 minus 3.
Yeah, it won't come inside this then. And at the end, I just need to do.
You do peak dot well, but even in the first for loop on the line 10, you need to do minimum of k comma matrix dot length. I think if you keep this min value of n comma k, which will be useful.
Which one, Naga?
Sorry, it's 2. Yeah.
Where?
Yeah, I think you can finish the code, but on line 10, you can take the minimum of matrix length comma k. If k was smaller, then you can just.
But the trick is.
I think this is fine.
Yeah, I think it's. Let's look into that later once we find the issue. Yeah.
So what I need to do is. I will remove one element.
Yeah, you need to remove one element and see if there are next things to add.
And then I would add the next element in the queue.
So since you added all the row elements, you need to make sure that you don't hit the column out of bounds. Yeah. Top of 1 is it? Yeah, must be less than.
So if it is
of 0 n only, yeah, it's n.
Then q dot add a new int where I will say top
0.
No, so it would be
no, the row is same, but like column will need to be +1. Yeah.
Top 1 +1 and comma
matrix of
top 2. Top 1 matrix.
top of 0, comma another index is top 1 +1. I think you need some brackets somewhere.
Yeah. Got confused with heap.
Yeah. Yeah. Now we are good.
Okay, and let's see. And yeah, K minus.
Yes.
I think K should go till greater than 1. It should not. So I think our top element should be here.
Yeah, K minus 1. Yeah, K minus 1 is greater than 0. Yeah, correct.
Okay.
Is line 14 n minus K?
No,
because you put n elements on the for loop in line 10. So you have to subtract that from K.
I think maybe it's needed. So K is like
So
if it
what
is
happens
8.
if K is less than n?
Can we?
Yeah,
Yeah.
I think that still
Start
you still need to check that actually.
Yeah. So if K is less than n, I think somewhere here have to remove the extra element.
Yeah, one thing.
If K is less than n, then like you could just pop the Q or the priority Q K times.
So
yeah, I think the 14 is not needed because we are already we are not removing the elements when we are adding on line 10, right? If you are removing, then we need to do K minus n.
Right.
Since we are only removing in the while loop of 16th, we don't need line 14. Yeah.
Correct. We actually don't need that. So our answer is the peak one, whichever is left.
Yeah, if we have removed K minus 1 in the priority queue, that's where our kth element will be on the top of the priority queue.
Yeah, so here the trick is when you are removing extra elements and whatever is left at the top is your answer.
Yes. So yeah, let's run this and just make sure.
Okay, let's see if this works.
Can you try K equals something less than n now, like 2 or?
Yeah, just try to.
So I would think you would still need that for line 14 actually, but let's see.
Because I can explain why, but
actually, if we put line 14, then it's a wrong solution. We will have trouble finding with the K less than n.
Yeah, in this case, we are removing, though we are adding in the line 10 all the 3 elements.
Yeah.
When it comes to 16 loop, we are only removing the 1 element because you are asking for 2, right? So among them, the min that you removed is 1. So the next minimum is the 5. That's how it's showing the answer.
So basically the answer is when you remove something and whatever is left at the top is the answer.
Yes, correct.
So basically we are removing K minus 1 times things and we get, so that's how it is working.
Okay.
Can you explain why K minus 1 have to be greater than 0?
Because if I remove K elements, then this would be wrong.
You will be returning K plus 1th element. Yeah.
Or then what I need to do is like...
oh, okay. Because base 0, right?
Yeah, so basically then I need to do like, I need to make this outside and then keep on tracking this guy. And
return top, yeah. Correct.
Then I need to do something like this. So whatever is removed last time is my answer.
Okay.
Can we try submitting also?
Which one? Sorry.
Just submitting the code.
Yeah, it's you have to initialize that to some number, so it's uninitialized right here.
Do I need to care about some edge cases?
Well, you could just try submitting like that. Test cases, the full test cases should take care of.
Yeah, correct.
Yeah. Okay. Cool.
Whether it was better than binary search, binary search was more.
Yeah, it's just that like using the priority queue. Yes.
I'm not talking I'm just telling like if people remember 2 weeks ago, we did the similar solution with binary search.
But
And
why
Yes,
why
yes.
it use less memory than binary search? A little more, huh?
might be problem.
Yeah, because we didn't use the queue.
I think we should actually compare the run. What is the complexity of this solution?
K log n.
It is k plus log k, I think, not even n. So
No, we are putting an element, right? In the
no, we are not putting. No, we are not putting n elements. We are only adding k times, right?
So here we put 10 elements.
So
no, oh sorry, yeah. The n, what you talk about n, that's what it's meant. If n you say is that n square, that's what like I meant. Yeah, it's not log of n square, but it's log of k plus log of k.
No, it's
because
log
you're doing k steps in while loop of
it is k log n, right?
Yes.
But the number of elements in the heap is also close to n. I mean, like the n in this case is not the total number of elements in the matrix. It's total of number of elements.
Okay, I understand. So so if you want to say that, row, k log rows, okay, that's perfect. And what do we remember? What was the complexity of binary search?
Oh no, that's a tricky question.
I think the number of rows plus log of rows into log row.
No, actually there the trick was the count function.
Okay.
So it was log n square, but the trick was the discount function, if people remember how we do the count part.
I see. Okay, now that's just for comparison. I think we are good with this. Now we can move.
Yeah, let's move on to the next problem.
This is good.
Thanks, Asim. Yeah. Let me share my screen. So the next problem is a similar one. I mean, like, but it is top k frequent words. It's like not a matrix. As you see, like there are some words here. I love lead code. I love coding. Then, like, if you want to return the top two frequent words, I love is been repeated two times, and those are the two most frequent words. And the order, as they suggest, since I comes before love, so they're just ensuring the alphabetical order in the result. Any approaches?
One thing we can probably do is create a map to count how many keys we saw. So basically, we'll go through the array and each word will start counting how many times we saw. Then do a heap of the frequencies. So basically the map will be from the word to count. And once that map, let us say that is the lookup table. Once the lookup table is built, we can create a heap which will where each node of the heap will be the frequency, a pair where the first one is the frequency and the second one is the word itself. So are you following me?
So I understood the frequency part, like, but how you are using heap, I didn't get.
So in the heap, we'll have to again write a custom comparator, because
which will use the maps count. Okay.
Yeah. So each element in the heap will be a tuple. The first one will be the frequency from the map, and the second one will be the word which has that frequency.
Okay. How many elements you will have in the heap?
Probably this will be the size of the heap will be the size of keys in the map. That is how I see.
Maybe we can do.
Yeah, I think once you start, Yeah, you can take up to the k. That's what is recommended.
We can do that also, correct. If we can make it a mean heap, then we can basically take the mean heap of size k, and until we have k elements in there, just keep pushing it. And once we have k elements, just see if the frequency is higher than whatever is coming in. If it is higher, then basically throw the top one and replace it with the new coming one. So by the end of the iteration, we'll have k elements which are the highest.
But if you already have a count, why you still need a heap?
The lookup table is not sorted. It's not like in any
Hash map is not sorted, right? You can have them in some random counter.
Yes, but like anytime, you know, we add the value to the value, we can keep track of, you know, how many in that, right? We can have
here,
variable to keep track of it.
Here k is equal to 2. What if k is, let's say, 100?
Then we only keep track of the one at 100. When the in the map, the key will be, let's say, the word, and the value will be the cow, right? So we only keep track of the one is 100.
But
yeah, I mean, like, yeah, but you don't know the count it until you finish looping the whole map, right? So you need like one iteration just to get the counts.
So we can put in the map. I think the trick is the complexity. So
yeah, correct. If you, the alternative of using the heap, I would say, like, I think we can use tree map where it sorts by, I don't know.
Can we use
tree map also is tricky, yeah, because you need to store the word comma count.
Okay.
Right?
Can we use the LFU in other way? Less frequently used, right? Cache. And in this case, we'll probably keep the most frequently used.
No, the thing is, unless we don't build the hash map, we don't know.
No. So we will build up, right? So cache also will be built up, right? So let's say I goes in the cache, then love goes in the cache, and then lit code goes in the cache. Then once we hit the I again, I come in the front, right? With the higher count, basically.
Yeah. So it's possible. Yeah, I think that works. We can always keep the most frequent in the front.
But how do you implement that LFU?
Using linked list. Using linked list.
Yeah, but
but
that
queue
LRU
solution
cache
is simpler than that.
Yeah, that's like a harder problem than this.
Yeah,
I see. Okay.
Yeah. So yeah, I think one iteration just to get the counts, and second iteration just to make sure that you keep only k elements in the priority queue, and then the priority queue will have the result, and just convert that to the result.
Yeah. So in this case, will the priority queue, based on like the first solution that somebody was discussing, it seemed like you were saying that it should actually be a min heap in this case?
Yeah, it should be a min heap, and if something is greater than your minimum already in the priority queue, then you poll, you evict and insert the new one.
Naga, I want to bring a point here. Why we are going towards heap? Basically, we have created the map. So, like say in my map, there are m distinct elements. So if I can even sort my map based on the count, then my complexity would be, if I use like merge sort, so my complexity would be m log m.
Yes, but with this, it's just log of.
So that's what I'm trying to bring down the complexity. We are going towards the heap solution. So I can bring down the complexity to m log k.
Even without map, if we just sort the entire list and then we iterate and see wherever the first element which have k frequency equal to k, that should be the answer.
Complexity would, if there are n elements, the complexity would be n log n.
Yes, correct. Yeah, in that case, you are sorting the words instead of.
The costly operation is sorting here. So I'm trying to bring that tension here that why we are going towards heap. I could easily do some sorting and get the answer. There is no hard thing of doing, but that is a costly operation of sorting. And to avoid that, that's sort like going towards heap to bring down the complexity. The whole, I think, if I see this problem in a way there where I'm trying to bring down the complexity. Because if I read the map, I could have used it like sort the map and even get the answer. But now I'm trying to bring down the complexity.
It can be possible that the number of votes are very large and the K you want is very small.
So using a heap solution, it would be like if there are m distinct entries in the map, it would end up like m log k rather than m log m. If k is really small than m, then m log k is a winner here.
So my idea, not using the heap was like, we still use a map, but beside the map we use a set, another set. So in this case, let's say k equal 2, right? And we see that there's 2 I and 2 love. So in that set we have I and love. Suppose that another love after this, then we know that love we have 3, count with 3. We remove that from the set. So at the end, whatever in the set will be the answer.
No, it is not that straightforward. What if you are removing from the set and that word comes again?
No, because it's more than the K already, right? So I only keep track of the one K equal 2, and when we add it to a map, we know the size of that word. I mean the count that word.
Yeah, I'm not understanding. I don't know. Like, do you want to explain?
Share your screen and explain it.
Okay.
Yeah, and please try to wrap it up
maybe
as soon
that's fine, because this is about
as
the heat,
possible,
right?
because we want to get to the.
Yeah, we don't want to take away the time, so keep going.
Okay, I think we can go with the heap solution.
Yeah, if somebody wants to implement this, please go ahead. And if you can start putting your thoughts or like your solution, meanwhile somebody codes. And if you want to share after they are done with the coding, that would be great also, so that we don't lose track of time. Yeah, because like the another problem takes more time because it's a diagram and understanding that may take some time. So I want to get to that also. Yeah, anyone volunteering to code this?
I can try. I may need some help, but I can try.
Yeah, sure. Now that you understood the solution, yeah. Please go ahead and start sharing your screen. Let me stop.
Sure. Okay, can you see my screen?
Yes.
Okay, so let's do C++. So the first thing is to create the lookup table. So lookup table will be a on-order map. Give me 1 second, I forgot all the syntax.
Yeah, I think you can use string and int, right? Yes.
Sorry?
Yeah, map, string and int. Do you have to be unordered map or?
Not necessary.
Not necessarily.
I think the order doesn't matter here.
Yeah. You just keep a map. That's what unordered map sounds good. Yeah.
So we'll say this is our table.
String comma integer, right? It's supposed to be count. Or...
Oh yeah. Integer or int?
Int. Yeah, I think I don't know the C++.
Okay. Give me 1 second. So now I will just do.
And just run.
I have got the words here. W in words. What we'll do is we'll basically table W plus equals to 1. By default, I think it is 0.
0. Okay.
Yeah. So now the table is created. Then we'll create our priority queue. So let me first write the custom comparator.
Yeah.
So the syntax is a little bit involved here, but I would say this is going to be a pair of basically string to int, and the first one will be the container is a vector of my pair of string to int, and then I wrote the completely okay. No, the first one is a pair. The second one will be also another pair. It is not a. Okay, so I would say this is P, this is Q. Return because I want to do the mean heap. I'll have to write the
minimum.
Actually, in C++, it is reversed. So, for example, I would have to say p dot first should be greater than first is the string and second is the this thing. So p dot second should be greater than q dot second. We'll come to the, but there is another thing also we see that we'll have to ensure that the I comes before, so it should be.
Yeah, that's a plain string comparison. Yeah, if you have the default string comparison,
here also
the count equals. Yeah,
so
the count equals.
We can say p greater than if okay p greater than second.
I think if it's equal to, then you need to do the string comparison. Else you do the
second. Then basically return p dot first is greater than p dot second. Else.
Said this is reversed, right? In
yeah, this is in C++. It is reversed.
Okay.
So let's see.
Default is max heap in C++.
Yeah, they use the less one, so default is max heap there. Correct.
Okay.
So now let's use the priority queue.
Line 11, we are doing P first greater than P second. What that mean?
So second is where our count is. The frequency are kept in the second, right?
Yeah, but what is, so P first is
oh yeah, I think you are comparing the second instead of it should be first in the line 11 at the end.
You're right. Yes.
Okay,
that's correct. Good guess. So priority queue,
it should be Q.
Then we'll say basically pair of string because we are defining our and it will be also a pair of string. Then
oh my god, it seems to be so.
yeah, it is a very messy. Yeah, it looks really complex there. So we'll say our priority queue is PQ. Quite a lot of things to write without any good reason, but that's fine. I don't know anything else. Okay, with that, priority queue is there. So we can again go through the, or basically iterate through the table. So for, we'll say const auto reference our pair. Say,
it should be words, right? Or
yeah, basically P in words. No, not words, it is table. Now we are reading from the table. Words was the...
Oh, okay, unordered map, sorry.
Yes, yes.
Yes.
So then we'll say PQ push basically P. Whatever words are there, just push it onto the... Oh, no. We can simply do that because we have got a main heap. So we want to see that, no, but let us do...
If PQ size is greater than K, you need to poll.
Correct. If you...
After the push you need to do actually. So after you push, if the sizes increases, then you need to...
Yes. If PQ dot size is greater than K, size is how we write size here. Let's see. I think size is like this, greater than K, and then
you just remove the top one. That's it.
Yeah, I just remove a three with a top one.
Yeah, after this you need to prepare the result. Yeah, this will just make sure that the...
I think we not return.
So when you so now you need to loop through the priority queue after this loop and prepare a result of vector string.
Correct. So now I have... Sorry?
It will be just a top element in the priority queue. That is it.
No. I think they want to return all the top K, not just the kth one.
Oh, okay.
So now we can simply say go through the priority queue. We'll say file PQ is not empty. Then basically say and now we will only return the... Oh, I'll have to also
just add the you need to add to the result some, yeah.
Top first.
And do we need at line 25 2 times pop?
There is one top, one pop. So basically, top. Yeah, it is how it works. So basically,
and at line 11, it should be PQ first greater than Q dot first.
Line 11.
Yeah.
Oh yeah, it's supposed to be Q, right?
P dot second is greater than Q dot second. Okay, that looks good to me.
Yeah,
looks good to me.
Don't know about the priority queue. Yeah, you can just try to execute some test cases.
Let's see, where is that run code?
Oh, copy that. Copy.
Oh, forgot.
Okay, it's there. Sometimes.
Okay. So run the code. Let's see. No member push. Push back.
Push underscore back.
Okay. Yeah. Okay, so it matched.
You want to take the second example and try?
Okay, where is the second one? This one.
Go to the test case.
Okay, I see. And then here I would say 4. Okay. Wrong answer.
Is expected.
The order is not correct.
The order is, yeah, the order is.
You need to reverse order, or the is needed. I think your order, the way you are adding, should be.
Yes. Because I took the mean heap. So when I popped it out,
Yeah, you need to reverse. Yeah, basically, when you're returning from, when you're adding to the vector, either you can add at the end, or like after adding you can reverse.
There is no reverse. I'll have to use the what is that?
Some collections variation. Some
there is this algorithm to revert it. I forgot the way to do it.
Yeah, it is reverse, and then retval dash begin and retval dot end. No, reverse won't return anything.
I see.
Yeah, just reverse and then return retval.
Okay. Now let us see. The first one should not have been.
Yeah.
Let's check the first one also.
I think if you submit also, then you will get to know if it fails on some test cases. So yeah, we can.
Okay.
Yeah, there is a comparison of the strings.
Yeah, because I.
You want to use, I mean, like you want to do the q dot first greater than, yeah, I think that one also might make sense.
Okay, now the second one should pass.
Yeah, I think it worked. Yeah.
Good.
So I think Leon also shared his code in the chart.
Yeah.
I use the one I used that I use the set as I described earlier. Can we look at it?
Could you please share your screen, Leon?
Oh, I put it on the chat. Somebody can.
Yeah.
Asking, can we come at the end if we get time in the session, because I want to see this Skyline problem. Otherwise, we won't get time for that.
Okay. Yeah.
Okay. Yeah, let's get to that. Otherwise, yeah, we can revisit it at the end.
I think Skyline is a really common problem, but difficult to understand.
Yeah. So can everyone see this? And
but seeing this also, I'm getting like headache.
I have this problem drawn on my whiteboard. I can probably switch to whiteboard. I don't know if it's okay in the live share mechanism. I can explain in whiteboard also.
Okay.
So firstly, I'll just probably try to explain here, then we'll switch to whiteboard. So the coordinates which is given in the Skyline is basically, they will give the start of the X, which is the 2 here, and the end is 9, and the height is 10. So the coordinates are given like 2, 9, and 10. So that's what we see here. 2, 9, and 10 is the height. And the other coordinate 3, 7, and 15. If you see 3, it's actually hidden. So the red bar, if you see here, it's actually hidden by blue bar, but it starts at 3 and it ends at 7, and the height is 15. So you can see the height is 15. And similarly, this green bar starts at 5, which is still again hidden by blue one, and ends at 12. So that you can see the green one ends at 12, and the height is 12. So the height is 12. So we are just given all this. I don't know why I keep getting this. Okay. So we are given all the start and end. Here also the end is hidden. because if you see 15 to 20, and here like again from 19 to 24 something other bar started. If you see, this is like, if you imagine this as the buildings, all of the buildings, and from what you can see from far, like some of them in this background will be hidden, like this red bar is hidden, right? And even this green one will be overshadowed by the red one. So the coordinates that we need to return is this, as you can see. And whenever there is no change, you don't return that, and you just return this. And you don't return this blue ending one. And you just don't need to do this because you are returning this. So this is the Skyline. Now probably I can switch to my whiteboard just and I'll give you guys to think about some solutions. So this is the Skyline points we want to return in the result.
So, but when you said we don't need to return on the green, the last point, right?
This one, yeah.
Yeah, but for the blue, the starting one also, there is nothing changed, right?
No, but this is the starting one, right? Which is visible on the left-hand side. There is nothing before that. So this is the first one which is visible. If something was, some bigger was appearing here, then probably that would have been hidden.
Or let's say that starting was 0. So at that point, basically it rose to 10. That's why we need to return.
Yes. Yeah.
Okay.
Yeah,
and similar way.
0. Yeah. Correct.
Yeah, and the similar way, when it come down to 0, we have to return. That is at 12 or whatever. Yes.
Yes. Correct.
Thank
you. So yeah, just keep thinking about the solutions. Let me try to switch to my camera. Let me. I will request everyone to pin my video. I'm not able to see myself in a picture. Yeah, seem like, how do I put like myself in a full view? I don't know if I'm able to show my full screen or not.
Yeah, but we can see you now.
Yeah. Naga, if you don't want to share, you can unshare your screen if you have everything on the whiteboard.
Oh yeah, I think that is a good point which I missed.
Anyways, people can open the problem like on their end.
Yeah. Yeah, now I am able to see even myself. Can everyone see the problem which I try to represent in best terms?
Yeah.
So the same points I actually given. Now you can also see this. This is 2 and this is 3, and from 3 to this is a 7, right? So this is a 15. So wherever I place the into mark, is part of the result. So this is the first building. Like initially you are 0, right? And when you are going through here, now there is a first building. You continue going to this Skyline, and then you continue going to the right, and then there is a change in height. You just go here, and you continue to the right, and you try to drop, and here you see like another building. So there is a change. You need to keep going right. So again, this is the point. This is the point, and this is the point. So any solutions like that you can think where you can use for today's topic? Use.
Priority queue.
How we can use a priority queues?
So it looks like each point has a start and end, right? So when it starts that height and when it ends that height. And probably somehow we put all this in priority queue, and basically at any point, the highest one we can get it. We should get it. I think we might have to do something if it is highest is starting or ending. Based on that, we might have to do some logic.
Yeah, correct. So yeah, this solution, like using queues, I inspired of seeing some Tushar Roy's video. So I think you guys can also look at his video later, the Skyline problem. It's
which video?
Tushar Roy.
Okay.
Yeah, his Skyline solution is same as what I'm talking now.
Okay.
So using the priority queues. So what we can actually do is, like, we are given this points, right? Like start of X, end of X, and then the height. So what we can actually do is we can divide each point into two equal, like one with the start and one with the end, like way Bhavesh was saying, right? So we take the start, which means that start X and what is his height, and we add to some list of points that we have. Like here I'm showing the list of points. Similarly, I add them, all of them, in the increasing order of X, from least to the last one. So I will start adding in the path, which is whether it's start or whether it's end. So first I have 2 and 10. So I add 2, 10 and start. The next I have in the list is 3. 3 is starting. So 3 is height is 15. So 3, 15, and it's a start. So next I have 5 and it's a start and it's ending at 12. I'm adding 5, 12 and start. So next I have 7, which is ending, 7 and 15, which is ending. I added 7, 15 and ending. So similarly, I have 9 and 10, which is again ending here. I added 9, 10 and end. So similarly, I have added all the points until the last 24 and 8. So this is also end. So we need to make sure that these are all sorted by, and there are some edge cases which we can come at the end. So I'll straight away get to the solution. So let's use the priority queue. In this case, we can actually have the, it is a max heap, or sorry, max heap, which in this priority queue, we can only track the heights. So far, what is the maximum height that I have seen? So that's the idea of using the max heap. Initially, when we start, so since there is nothing up here, you can add the current maximum height is 0, right? So now when I visit the first one, which is 2 and 10, now my max height is like 10, right? So the max height so far that we have seen, it's now got changed to 10. So whenever you add something to the, whenever you add a start, and I mean, like if the height changes, you can add this right away to the result. So let's take this as a result points, and then we can add this to comma 10. This is one of the result point that we have actually captured here. Next we add 3, 15. So when we add height to the priority queue, I add 15 and my max value got changed, and this will become 15. So since the max value got changed, I can actually add even this 3, 15 to the result. That is my next one. And now there is a 5, 12. So I add 5, 12 here. So if I add 12 to this priority queue, whether my max height in the priority queue changed? No, it is still 15. So I don't do anything. So I continue to the 7, 15. I don't add anything at this point to the result. I'm done processing this 5, 12. The next one is like 7 and 15. So this is the end point. So for the end, so now since I'm removing this 15, If you remove 15, what is the max one? Max one became 12. So we need to insert this max height and what is the current end one, 7x. So I will insert 7, comma, this current max height, 12. This you need to add to the result because the max height got changed and my current x is 7. Is this clear? So I added this point to the result now. And now the next point that we have after 7, 15 is like 9 and 10. I have the 9 and 10 and end. So you have the 10. You remove this. But like if you on removing this, you don't see the max height got changed, right? So there is no change. So you don't insert anything to the result. The max height is still 12.
One question there. Because it is a heap, we are not able to remove it any non-top element.
Yeah, correct. That's a good question. So I said like it's a max heap. We definitely for like coding this purpose, like we definitely need either the index priority queues, which has the ability to remove an element, a certain element, or we need to use a self-balanced binary trees like in this case, like the tree map can be used because it's internally red black tree implementation. So the tree maps can efficiently remove in log n time, unlike the priority queues. But just to understand, I'm explaining the with priority queues. But when we get to code, like since it cannot remove like a given element directly, so we need to rely on other one.
Can you explain, Naga, why we were removing things?
Because we are seeing the end, right? Like if I'm actually now in the start, we keep adding, but in the end we keep removing from the priority queue.
Priority queue adds the height, right?
So this priority queue, I mean, like in this priority queue, what we need to ensure that we always get the latest height, maximum height. On for the starts, if you are adding and if something changes, then that is something that we need to capture according to our solution. But for the end, when you remove the max, I mean, like whatever the end that you have, that actually changed your max height. So since after removing this, the next maximum height is 12 in the priority queue. So that's what you added to the result for the end. And now you have 9, 10 and end, right? So I'm also removing this 9, 10, which is the end from the priority queue, but still it doesn't change my maximum height, which I have so far in the priority queue. And I'm not adding anything on processing this end entry. Is that clear? Or just that like the way we are processing the start end is there is a little variation. For the end, we try to also remove from the priority queue. For start, we keep adding items to the priority queue.
Or maybe do a while loop and keep on removing from the top in the main heap till we don't get that value, and when we get that value again push them back. Something like
That's what like that is possible using the max heap, but the only thing is the time complexity increases.
Right, yeah.
So to overcome that, we can use some other
Naga,
existing today.
Can we keep in the heap? It is always ordered by, let's say, X, and then ordered by height. Is it possible?
Ordered by
X and then ordered by height, and then basically we put everything in the map, everything in the priority queue upfront, and then we just keep removing from top.
No, actually, we I want to keep all this building start and endpoint separately and process one by one, and we only add items from this list only if it's a start, and we try to remove this building point if it's an end. So whenever we see the starts, we keep adding the elements, and if we see the end, we keep removing from the priority queue. Only for that I'm using, only for adding the heights and removing the heights. So otherwise, we still want to keep all these points sorted by X, like from start to end, right? And there are still some edge cases which we'll get to after finishing up this.
Okay.
So now, like, we have finished like 9, 10 ending, and I removed the 10, and my max height didn't change. I didn't insert anything. Next one that I have is 12, which is here, 12 and 12. So this end, and 12 is the maximum. So I need to remove this maximum because it's an end. If I remove 12, what is my current maximum? It's 0. So I add my current X, which is 12, and what is my current max height? 0. So this is my next point in the result. So only thing is, for end, after removing whatever was the maximum height, that's what we need to add to this. And the next point that we have is 15 and 10. So the 15 and 10. So it's a start. I add to the priority queue, and that actually changed my max height. So it is 10. So since it changed, so I need to insert this 15, 10 as is to the result. So let me actually move this because it's not visible. 15, 10, I added to the result. The next point that we have is 19, 8, which is again start. So I add 8 here, and my max height in the priority queue didn't change. It is still 10. So I don't do anything with this start. I move to the next one, which is 20, 10. So next is 20 and 10, which is an end. So, and my max is 10. I try to remove this element, which is 10 of the end. If I remove this, my max height is 8. It is changed. Now that it's changed, we need to insert this 20, the new height. So this 20, height. Now only remaining is 24, 8. So this 8 is there. So we need to remove this 8 because it's end. So after removing, it became 0. So we need to change this current max height became 0. And now this 24 is the current X we have. And then this is the 0, which is the result. Now we are done finishing all the skyline. Now that if we draw something this, we should get the same coordinates that is actually there in the result. Any questions so far? Like I might have moved a little fast here.
Is that enough to draw the skyline? Is it only a vertical line? That those points only vertical line, right?
Yeah, these points. Yeah, are you saying to draw the? Now let's draw and just try to visualize, right? Like we start going from. Let me use some other marker.
I think maybe he's asking like you can have a diagonal, like increasing or decreasing line.
No, diagonal is not possible. You always need to go in like straight lines. From the 0, we continue going to the until we hit the first point. And now from 2 to 10, like we keep going here. And from 10, like from the next thing is like from 2 to 3, we need to keep going again this way. And in the 3, it's still like 15, right? Next point is 3 to 15. And we keep going until we see a next change in this point. So this is like 7, 12. You just come until here and you keep going right. And we have a point here. So you just keep coming down. and then like you keep going down because this is our next point, right? And you keep going up till you hit that point, and then continue going right and go to the next point. And once you hit, you keep going right, and then you hit to the actual point. So this red line represents as our skyline. So that's what is expected in the result. I don't know if red is visible. I tried just to draw.
Naga,
Mm-hmm.
the input list that you wrote in there, is that how the input was given?
No, it is not given in that way. So the input is given in 3 coordinates. One is the x1 and x2. Like in this case, the 2 and 9 and 10. So we need to split each coordinate into 2 halves. One as a start and another one as an end. So this 2 and 9 was given as one coordinate. And I split this into 2 points, like of start and end separately, because like we need to process in the increasing order of points, like in the order of x.
So how did you come up with, from the given input, how did you come up with that list of inputs? How did you transform the given inputs into that list?
Yeah, so let me just draw that. If you, I'll just quickly draw those list of points here. I think it's visible, right?
Yeah, it is.
So we are given like x1, x2, and then the height. So we are given like 2, 9, and 10. This is our input. And we are given like 3, 7, and 15. And we are given like 5 and 12. And the height is 12. And the next one
15, 20, 10.
15, 20, 10. Thank you.
19, 24, 8.
19, 24, 8. Okay. So these are the 5 points that 5 buildings that we were given, x1, x2, and their height. So each building we split into 2 points. So this came here, one as a starting, and another one here ending. So similarly, this 3, 7, 15 got split up 2 times. One here, another 7, 15. Where is it here? So similarly, like each point we split into start and end, and we can add this into an list and just sort based on their x. There are a few other edge conditions which I will talk about now, and those edge conditions also need to be accounted in the starting. So
okay,
cases. Yeah, there are like, let me actually draw the edge cases here. So I think it is visible, right? Okay. So let's say if I have a building here and you have another small building, and there may be another edge case where you just have another building ending in the same, this one. Here you have 2 buildings starting in the same position. So in this edge case, like since both are the start, right, you need to add 2 points here. So one with this height, one with this height. So when you are adding here, if two items, if you have x as the same, then what you need to make sure is you always keep the highest one first in this order, sort order. So if you need to keep this highest one always first in this order. Otherwise, like only if you keep this first, then only you will add this to the skyline. If you keep the smaller one first, you may end up adding this to the skyline, which is not correct. So this is wrong. So this is one of the edge cases where one building is completely overlaid by another building. You just need to make sure that you add the highest building starting point first before adding the smallest building starting point. And in this scenario, similarly, you have the highest one and the lowest one, right? But this is not actually part of the answer. When it is n, you need to add the smallest one first and then the bigger one, because that is not part of the skyline, but this one. I don't know if that one also is, but like you just need to make sure that you add the smallest one first. when it is coming to the end. So that like when you remove this, there is no change. And when you remove this, next time it will be 0. So this is what you add to the result. Is that clear?
Could you please repeat the second one? I mean, could you please repeat the last one?
Okay. So if the, say this height was like 15 and this was like 8 and this is, we know 0, right? So if you store the highest one first, since you remove the highest one, the next one is 8, you treat like your max height got changed in the priority queue. But it isn't supposed to be in the solution. So when it comes to end of the building heights, what you need to make sure is you keep the smallest one first. So 8, this building point first in your sorted order here. So whenever you see some excess matching and even the end heights, for the ends, the heights should be the smallest first and then the next highest first. If you add 58 first and 15 next, if you're removing 8, doesn't actually change your max value. On removing 15, it will actually change because after removing this 2, your only available was 0. So you will add actually 0 as the result here because that's a new height and you add that X along with the 0.
Could you give a similar example on the first one?
For this, suppose like you have the 2 buildings, like if these 2 buildings were starting at the same position, then this 210 is not an answer. So it should be begin with 315, right? Imagine this was 3 and then 10 and 15. So for the start, you need to always make sure that the biggest is in the first. So the 3, 15 should come first before 3, 10 building. I mean, like I'm talking about only with respect to starting points. If you have 2 building points, both are start, you just need to make sure that whichever is the highest height, that comes first in your sorted order, whatever the list that you are keeping. But for the ending building, you just need to make sure that you need to reverse this. If this was an end building, suppose this was like some 15 and this height was again 15 end, and then you have for the same 15, if there was another 8 end, you just need to make sure that the smallest one appears first when it comes to end, and then the bigger one appears next in the sorted order. This is just to make sure that you ignore all the smaller ones first, and when you ignore the bigger one, the only next remaining item is like 0, which changes your max priority, max heap height, and then your result, you will be inserting this as a I mean, like in this case, you always see that you always add the 0, right, when it drops. So if there are like so many buildings here, you always need to ignore all, like if you imagine some buildings here, points, all ending in the same thing, you need to ignore all of this and only add this building point in the result. So that's why you need to ensure this sorted order for endings. Was that clear?
Yes.
Okay. Yeah. Thank you. I think these are the 2 conditions. I think there may be few other edge cases. I think, but that's okay. If there is a building entirely surrounded by this, I think it's still with respect to start and end points, like another edge case could be if one is starting here, but other one is ending here. So that's another edge case I wanted to talk. In this case, we just need to make sure that the start point always comes before the end point. So this is an endpoint, right? One of them, like if this was 7 and this was like 11 and this was like 8. So our sorted order should be like this is start and then 11 comma whatever this it's 12. So 12 start and then 11 comma 8 end. So we just need to make sure that if there are two overlapping, the start comes before end. So that is another edge case. Any questions on this so far? We can move on to the code because we have only few minutes, only 10 minutes left. I don't know if someone will get opportunity to. Otherwise, I can show the code which I implemented on the similar lines. So you can also try to visit the Tushar Rai's video because he explained in the same fashion on the same approach that I explained. I mean, like I took inspiration from his video only because most of the other solutions I couldn't follow easily, and this is like clear way to approach the solution. So I can quickly show my code, or if somebody volunteers to write, they can write as well.
Naga, can we quickly check complexity?
Oh, okay. Time complexity. So on the time complexity, as you know, like if this number of building points are like, let's say n, then we are adding at least twice the points in our list, right? So let's say 2 star n, and we are actually sorting this. So another log of 2 star n. This is just for this. And for adding the priority queue, it will be like plus of. In the priority queue, I don't think we'll have like so much of these points. Like maybe we can just say at least the log of half at the maximum. So plus log of, I think into log n maybe.
Are you doing the space complexity or the time complexity?
Yeah, this is the time complexity to like 2 into n and log of 2 to n, right? It's equivalent of n log n.
Yeah, time complexity.
Yeah, so that is for sorting, and for the priority queue,
in worst case, how many element will be there in priority queue?
In the worst case, n. That's the n.
Okay, so we can take that.
Yeah. So and since for n times we are actually looping through all this, so we can just say it will be like n log n plus n log n, but since the number of building points is 2 star n, we can try to show like 2 star n into log n, which is again the same time taken by the sorting. And we'll try to loop all through this 2n points. And each time we try to add, if it's a starting point or ending point, we keep adding the log n, right? We always do that log n operation on the priority queue. So it's like 2n log n into 2n log n. I mean, like plus 2n log n. It's like n log n if we ignore the constants.
Okay.
And that removal of the non-top node, what is the
Yeah, that is also logged in, right? Like if you are using that self-balanced BSTs like map, it will be log n only for removals also. But if you are using the plain priority queues, then you need to actually it will go the worst case of n in that case for removals. It might become n square if you use a plain priority queue. But if you use like index priority queues or like maps like self-balanced BSTs, in place of this, you can actually make sure that this is the time complexity.
Okay.
Yeah, if there are no more questions, I can just switch to code and show how it actually is implemented.
Yeah, we should do.
Okay. I'll stop the camera. I think if I stop the video, Let me share my screen. Let me see my submissions. Sorry. I hope everyone can see my screen, right?
Yes.
Okay.
Yes.
So as you can see, I just introduced one building point with X and Y and whether it is start or not. And initially what I'm actually doing is looping through all the buildings and create 2 points, one for the start and one for the end with the same height and with the start and end. And I'm actually sorting this list based on the logic which I actually told. So whichever is the smallest X, that's what should appear first. And if both are start, then the one with highest height should appear first. And if both are end, the lowest one should appear first. And if one is start and other one is end, then the start should appear first. So that's our sort logic. And now, like in place of priority queue, I'm actually using the tree map. So initially, like for the first time, like we can just assume that we have the 0, right, which is the maximum height. So the key is what I'm actually treating like a maximum height here. So the other one you can actually ignore. So whenever we visit the start, we are actually updating the priority queue with that height, which is the key, and the value you can just it may be like the counter. You can just ignore the value. The main thing is the key. And if it's the end, you just make sure that you are removing that. And whenever this height changes, the maximum height, the last key is like the greatest key, like the maximum in the tree map. So you always check this, whether the previous height, initially it was 0, is different from the current max height. So whenever it is changed, then we are adding this building point of X and comma whatever the new changed height. So, and once you are done, I mean, like once you loop through all this and just follow these steps, like that is good enough. So in the tree map, the main thing is the key, which is acting as a height here. So you can ignore like what is stored in the values here. Like value is like the number of, I think the value is the number of times that height has appeared. So I mean, like if the same height was appeared multiple times, then we just make sure that we remove when it hits 0. Yeah, I think that's correct. So any questions on this code? Yeah, I hope, I mean, like I tried to explain the Skyline better. I mean, like at least in an understandable way. If not, you can also read the Tushar Roy's video once again. If you can Google, that's the first video, it comes for Skyline. So I think some of the companies tend to ask this hard problem and see how you try to solve. So I never come across with this, but I heard few friends who told that they got this problem in the interviews.
Could you please share your code in our Slack channel or somewhere?
Yeah, I can share. Yeah. Okay.
Could you go back to it for just a minute? Could you go back to the code for just a minute?
Okay. Yeah, I'm actually going to there.
The sorting is tricky.
Yeah, sorting is the one which does half of the work.
Yeah, sorting take care of edge cases here.
Yeah, so yeah, all the edge cases is taken care by sorting here. Any questions on the code?
So the way the lead code solution shows, it's not using queues, right? The priority queue, it is using something else, right?
Yeah, I mean, like I found it hard for lead code solutions to understand. I mean, like there is a divide and conquer
Divide and
approach,
conquer.
which may be, I mean, like, but the code and the way, like I found it's little trickier in this solution than the priority queue. But I don't know, up to you guys. But I found this is too much of a code for this. It's a divide and conquer, but like I mean, like I felt like the priority queue solution was better than divide and conquer.
Mm-hmm.
So I chose to explain this. Okay.
Will you be sharing your solution to the same where the handout is posted, Naga?
Yeah, I'll convert this to a .java file and upload there. I
Okay.
think, and then I'll.
So we will access that later also.
Okay.
Okay. Is there any question on this?
Yeah, if no questions, maybe we can end, right?
Yeah, we can end recording and then do other discussion if we want to come back that.
Okay. Okay.
Vivek?